Welcome back to Ox Tools. I'm Tom. So building another meatloaf here, number 28, I believe. It's ratcheting up pretty fast. So in this one we got some viewer appreciation boxes we're going to open up and take a look at, and look at some of the goodies that are in there. These guys have sent from all over the country. We're going to work on the X-ray plug for the energy fabricator down in Australia, and what we'll be doing on that is we're going to do a tool bit grind. I need to make a face groove for an O-ring, and he gave me some more details on that changed the size of the O-ring a little bit. No big deal. So I got the O-ring here, and so we're going to make an O-ring grooving tool for doing a face groove, and we'll probably start working on the body of the plug and turning it down, and and threading it and doing all that stuff too. And then the last thing I wanted to mention was we have a viewer in Columbus, Ohio. His name is Eric, and Eric has a big old Springfield lathe, and this is actually a big heavy-duty industrial machine. It's kind of a tank. Anyway, it's missing the chip pan, okay, and it had a sheet metal or sheet metal slide out chip pan. And Eric doesn't have any ability to weld or bend up sheet metal or anything. So if there's any viewers in the Columbus, Ohio area, give me a buzz. Here's the secret email address up here, okay? Drop me a note, and if you think you might be able to help Eric out with his Springfield lathe chip pan with a little bit of sheet metal and welding, I believe he's willing to pay, or you guys can horse trade. I'll leave that all up to you. But anyway, he needs a little bit of help with his chip pan for his lathe. So any of you guys out there in the Columbus, Ohio region, drop me a note and I'll connect you guys together. Okay, so let's suit up and let's get going here. Okay, so this first one comes from an old friend of mine down in Los Angeles, and his name is John Marcus, and he has a little company. Well, I don't know how little it is, but he's got a company down there that makes instruments for checking durometers of rubbers and things like that. It's called PTC Instruments. Anyway, he's in Southern California. Anyway, he's been getting into tool making a little bit and playing around, and he sent me this little guy here, and this is kind of cool. And what is it called here? He calls it a finger plate, and it's from the Machinist Bedside Reader. He says the base is A2 tool steel, and it feels hard, like it's heat treated. Let's take this off and have a look at it here. So there's a couple things. It's got this cool little washer. I guess it's the washer can rock too, which is kind of interesting and compensate for little misalignments. And these are kind of nice fingers here. They're open, which is interesting. And then they have threaded holes for heel screws. And does that fit on there? No, it does not. Does not look like it fits on there. This is a double ender here and a single ender here. And it looks like these feel hard too, and like he might have, and then he surface ground them. So it's got some little finger grabs here, which is kind of nice. And then some, I guess those kind of, oh, that's so you can clamp this down here, okay. Like that. That's what those little slots are for, so you can hold this down to the mill table. Anyway, that looks kind of cool. It's kind of like another little V-block there. Looks like the V-groove is machined and not ground, but that's okay. Looks pretty good. So we'll try that out and see how it works. Thank you very much, John. And John's making one of the squareness comparators that I designed. Anyway, like I said, he's getting into tool making and starting to mess around with this. John, thank you very much. I really appreciate it. That's a nice little gift, and we'll try it out and see how it goes. Thanks. Okay, so here's our X-ray plug. that I got from Nick down in Australia, energy fabricator. Anyway, so I redrew it. He gave me some more details on this thing. And apparently the plate, the mounting plate here, has a radius at this corner here that we have to accommodate. So I had to change the size of the O-ring a little bit. So we're going up to a much larger O-ring here. Now, the O-ring's going to sit right like this in that area. It's going to be a face seal, so there's your O-ring like that. Okay, and we're going to use so we got a little bit of an access problem there, okay, for our grooving tool. And so normally what you would do is you use a tool that has a crook in it like that you can come up along the side here and do a face groove. So here's an example here where we're coming up alongside this, and we need to make a groove near the root between the cylindrical part and the face here. Okay, now this particular groove is about 160 thousandths wide, so it's pretty good size. Closest tool I had was this one here that's got a little crook in it, so it'll sidle up alongside here like that. So what we're going to do, just for fun, is, let's see, let me set that there. And here's another one that's the other hand here for a skinnier groove even. So I figured what we'd do is we'd go ahead and let's grind one up. Since you guys seem to like these tool bit videos, we'll go ahead and we'll mark one out on this and then grind it up for that groove width there. So that's what we're going to do. Okay, so this next one comes to us from kind of semi-local guy, Ray Caniglia. And please find and enclose your own shop universal repair kit and goodie grab bag. He's also sent, he says, I sent a light duty kit to Adam, Chuck, and Stan. Your kit is extra special and it contains an assortment of zip ties, screw clamps, black electrical tapes, snips, a sharpener, and some machine shop items that I thought you might like. So I guess I'm last to kind of show this particular package here, and but let's pop through it real quick. You've seen everybody else's. There's a little sharpener for the scissors. Okay, and let's see if I can find the scissors here. Here's the scissors, and these are really great scissors here. They're heavy duty, and it's got a little side sharpening thing for the scissors there. So yeah, these are insulation or lineman's scissors here, pretty nice. All right, let's set that aside. We'll just keep going here. You've seen most of this kind of stuff. Okay, here's some stretch tape. Now, when I first looked at this tape, I was like, hey, wait a second. This label looked slightly Harbor Freightish, but on closer inspection, this is actually really nice tape here. It's not Scotch 33, but it's nice. It's real heavy, 8.5 mil thick tape, so that's pretty good. And a mil, it's not a millimeter, it's a thousandth of an inch, so that's 8.5 thousandths thick. So, okay, so zip ties, some nice long ones. That's a good size. Everybody likes those. Then we got, okay, so these are those little screw down clamps that he mentioned. And then, okay, this must be one of the little machine shop items here. Looks like one of those Eagle oilers. Wow, that's pretty nice, Ray. Thanks. Oh, smells like it might have had whey lube in it or something like that. Oop, shit. Excuse me. It works. Looks like it's got had a little something in it. All right, thank you. That's really nice. All right, let's see what else we got. Oh, some more ties. All right. Oh, more ties. I don't think I'm ever going to have to get any more nylon ties in my entire life. I think I'm set. These are a really good length here. Oh, there's a couple more things in there. Let's see what else we got. Oh, wow. That's a nice little indicator. That's a cute one. So that one's got a balanced dial there. So 0, so it's got 0, -10, +10, right? So it reads in either direction. So you can do kind of a high-low with that. That's pretty cool. Federal. That's a Miracle Movement. That's a really nice one. Got a funny back on it though. We'll have to sort that out. Let's see what else we got. Oh, another indicator. A similar funny back. These look like they came off gauges or something like that. Once again, it's got the balanced dial plus or minus. So, wow, Ray, thank you very much, man. This is awesome. And this is extra special. Thank you very much. All right, so let's go ahead and mark some stuff on here just so we get some kind of guidelines here. We don't need a lot of depth here. Yeah, this is not marking real great here. Something like that. We'll start with that. And then that'll be kind of square with the world there. Hopefully you can see that. It's not an easy thing to show. I just kind of clean the end of the tool off a little bit. So it just gives me something to kind of guide my work a little bit, and then I'll be measuring that as I go along. So let's go over to the bench grinder. So, you know, we're mimicking that, okay? Just, you know, for guys that are wondering, okay? And you can see it's relieved underneath too. All right, and then the side relief here is what we care about here, you know, how the sides are relieved so that it clears in the groove. Okay, so let's go over to the bench grinder. Okay, so this next one's actually kind of interesting. This comes to us from Joe Hale in Florida. Anyway, he thought I needed a new forklift to lift my hammer collection. Anyway, I've been having fun with it. It's kind of fun. Uh-oh, dropped the load. I got a nut in there inside the crate. Anyway, it's kind of fun. It actually works pretty good. Uh-oh, back up, down. Anyway, it's pretty cool. It uses AAA batteries in there and a little 9-volt and a little remote, and it's kind of fun to play around with. So, Joe, thank you very much. Nice joke, and I'll use it to lift some hammers. It's actually fairly powerful. You can hear it groaning on that. Anyway, thanks a lot, Joe. Appreciate it. Okay. All right, so I think we're ready to go here. More. Well, I'm going to straighten the face out in relation to that edge that I've just established.
start taking away this side here. Now this is a Momax Cobalt, so it's a little harder to grind than just plain high speed. Starting to take shape. Actually, that's probably see, and we got our reliefs in there naturally, so I can lean on the top a little more. That looks better. Now you saw me pick that up a little bit and hold it in my hand. Sometimes when you're down against the tool rest, it rattles, and it's easier to put a little more pressure on it when it's up. Anyway, there's the end. You can see the side reliefs there, and I'm probably going to get some calipers in a minute to start measuring that thing. Make sure I don't. So we're about 1/4 inch right now, 6 millimeters or something. So. Looking pretty good. Okay. Well, it's actually pretty tasty there. Well, I'm gonna go get some calipers. Okay, so we're a little over 200 right now. So I'm gonna go a little more, and then I'll work the outside since it's the easiest side to access, to bring it down to the final width. This inner edge is looking pretty good here. I may, I'm gonna roll it a little bit to give it a little more relief, and then I'll shorten it up too. And then to bring the final width in, I'll work that one side. So. Well, what are you doing there, Mr. Wizard? Okay, I can feel the pressure is going up a little bit. Give it a little dress. Okay. Alright, I think I'm going to change the camera angle a little bit so you guys can see from the other side here. Okay, so this the next one here comes to us from Ken Bartlett, and it's viewer appreciation. I appreciate all the great videos. I still don't have a metal lathe, but when I do, watching all your videos will help. I see you writing on all types of materials, so I thought you could use this workshop, sketch, pencil, extra lead kit. Lead for writing on, lead for writing on metals, huh? That's interesting. Oh yeah, looks like it kind of works. Okay. Glass or wood, plus a pen for you and a pen for the missus. So this is the pen for Mrs. Ox here, and it's got an appropriate gem in it. This is kind of the fancy version here, and this one has the screw in and out. And then this guy here has it's a push button, okay. And then this one here is kind of neat because it's a collet. It's a collet setup that holds a lead, and I guess there's a couple kinds of lead here. I'm not going to pull those out, but this one feels pretty good here. Actually, it's nice and fat. Fits my my thick hand. Anyway, Ken, these are very nice. Thank you very much, and I really appreciate it. And thank you very much for the thoughtful gift. We'll put these to use around the shop. We're getting pretty close now. Keep the front in order here now. And the tool is tapered as we go back, so when you take some off of the front, it actually gets skinnier. So you got to be a little bit, when you get close, you got to be careful that you're getting it all kind of together at once. I forgot my number. I got to go look at my number. So I changed the exposure on the camera a little bit for this next little segment here. It was kind of getting washed out at what it looked like to me, so see how it works. And I got the autofocus on now, so alright, we're getting real close. I want to be about 160. I got about 7 thousandths to go here. So my side reliefs look pretty good. I got a couple degrees there, a couple degrees there, and the front looks pretty good. And side looks pretty good. I'm pretty happy. I don't know. Actually, what I want to do, at this point, is kind of clean it up a little bit so it's nice and flat. 159. I think that's what we're going to use. And the tolerance is 153 to 156 to 163, something like that is the groove tolerance. So now that leaves a little bit for honing, and we'll give this a little test, make sure the cut's right, and do our O-ring groove. I almost forgot, I got to remove some off of the bottom here. Since the groove is curved, this lower part would interfere. So the trick is to take enough of it away, but not too much. That looks pretty good. We're just cutting brass, so that's a pretty sturdy looking tool still. Yeah, I think that'll work fine. And yeah, I should do something on top there. Yeah, I think I'll do the top on the diamond wheel because it's nice and flat. Well, you know what? I don't know. What are we gonna do here? We got a little edge in the top. We'll do a little honing on that, and that will cut like a banshee. Okay, so the last one, you guys have all seen my my green trays here that I put stuff in to carry it around the shop. And no, these did not come from Mickey D's. These came from there's a restaurant supply place not far from here, and they're $2.95, so I bought a handful of them, and they're kind of nice for around the shop just to kind of keep things from rolling around. Anyway, one of the viewers, Eric Haar, apparently works for a molding company that makes these trays, and so he said, oh hey, who are those trays made by, you know? And apparently the Thunder Group is not who he works for. Anyway, so he decided to send me one of the type that comes or that he molds, and that's this one here, and this is put out by Carlisle, and but this one's fiberglass. This one is actually really nice here, and it's got this kind of rubberized coating on it here. This kind of non-skid stuff. This thing, weighs like 3 times what this one weighs here. Anyway, this is a really nice one. I'm going to use the heck out of that. And just as a joke for shop decorations, he sent me some stickers to kind of go with it. And so you'll see those in the, oh yeah, all good things come from McMahon. Oh, what do we got here? I didn't see this before. Oh, it's about time. It's good. I was like, why? Why isn't there a darn note with this thing here? So, oh, okay, yeah, cool. I'm not going to read the whole thing. Encloses my secret weapon in rebuilding jet ski carbs and other items containing small parts. It's not a direct replacement for your green cafeteria tray, but it might prove useful at some other point. Decals are left over from years ago, originally intended for a dumpster. How perfect. We'll put those in the shop. How appropriate. So anyway, Eric, thank you very much. That's really nice. I really like this tray. This is pretty cool. So I'll do a little testing on it and see how it goes. Thank you very much. All right, so we're just going to hone this a little bit. And then, let's see, can you see that? I don't know if I can do this left-handed. So I want just a tiny little corner radius there. Kind of hard to do left-handed, but hey, anything for the viewers, right? We'll try it. Oh yeah. Doesn't need much. Now this other one's going to be a little harder here. Okay. That looks pretty, ooh, that's pretty sharp. That in there. All right, I think we're ready for a little. We'll do a little test groove and see what it looks like. Okay, so this is the actual brass bar stock we're going to use for this plug. So what I'm going to do is I'm just going to face the end of this, and then we're going to set up our grooving tool, and we'll just do a little test. Facing cut in that, so okay, so let's get that out of there. And we got this guy here, and let's, I'm pretty sure it needs to come up. Yeah, let's get it close to center to start with. Yeah, all right, that looks pretty good. And then I just have a shim underneath it, so I'm going to leave it a little bit loose here so I can scoot it around. And then I'm just going to come up until I like the look of it. Like that. So what I'm doing is I'm just pushing it out of alignment slightly and then bumping it in Z to get it to seat the way, I don't know, it looks pretty good to me. All right, let's try that. Alright, let's sneak in there. Yeah, alright, that looks pretty good. So let's do this. I'll come up, we'll try one here and see what it looks like. Okay, so you can see it's touching down on that outer corner first. Alright, so we need to make a little adjustment. Let's make a little adjustment. All right, so I just moved it a teeny bit. Let's try that again. It's not, in this case, it's not super critical that it's perfect. It's just good practice to have a nice flat bottom groove there. One more time. Alright, so you saw it got wide fast, so it's getting close. Since you guys are watching, I'm gonna try to do it really good here. It's surprising how much you move it just to get that little change. Let's do it. Let it come out here. Alright, that's pretty good. Let me make sure those are tight. Yeah, that's pretty tight. So we'll just try going in a little bit. Alright. Yeah, it looks pretty tasty to me. Good enough for the Australians, eh? Okay, so let me face that off and then we'll start turning. I think we got a good tool there. And I'll face that off again and we'll start turning. Actually, I don't even need to face it. I can just start turning it and making this plug piece. I slipped it out. One thing I forgot is we can actually measure it with pins. So let me grab a pin. I think we're around 160. All right, that's a. Yeah, almost fell in the chip pin. So that's a 160 pin, and that seemed a little tight. Let's try a 158. Okay, 158's going. So around 159, something like that. That's going right in there, and the 160 didn't. So we're going to call it 159. And so now I got a good, I know what size groove it's going to produce. So what we do initially is establish one side of the groove and then move out or in, whichever way your reference is, to make the groove the exact width that you want to make it and the depth. But this is another good use for gauge pins, is checking stuff like that, which can be a little bit tricky to check. So. Okay, so I think we're ready. Let's start turning here. Guess I better grab my drawing, huh? Wouldn't want to blow that one. Okay, let's do a facing cut first. Z-axis on my facing cut here. Alright, that looks pretty happy. So then I'm going to come in and, I'm going to set my my depth, which is 473. Do that. I'm just going to put a witness mark right there that I can see, and then work my way up to that. chip got caught behind the insert there, so I was jamming it up. Okay, that's just a rough shoulder. And I'm going to take a light cut at a different feed rate to get a good measurement to calibrate the tool, the diameter, I should say. Get a micrometer and we'll check that. Alright, so we're 1 inch 9 thousandths, so 1.009, enter, okay. And then we're going down to 709. There. You see the chip behavior at a different feed rate is kind of interesting there. The chips aren't actually breaking. So the different feed rate doesn't, so here's the chip we got off of that, right? A long skinny one there. So actually now I need a different micrometer. I should have grabbed two. Alright. We're going to get close now. We're at about 720. Yeah, okay, that's pretty good. The DRO is tracking nicely. All right, so I think I'm going to go right down to my my threading diameter there. Face that off. That's looking pretty good. So I'm going to put a thread relief back there, and then I'm going to calibrate my grooving tool because I have a known diameter here now, or a diameter that I can measure easily, and that allows me to position the O-ring groove really easily. So we'll set that up next.